90% of the Toyota owners pulling into my shop this month are actively killing their cars. And the worst part is, they are paying premium dealership prices to do it. We have been conditioned to believe that if you buy a modern, overbuilt Japanese powertrain, you are buying an invincible machine that can handle any daily commute without a second thought. The manufacturer sells you on the dream of a 300,000-mile bulletproof engine, and the dealer tells you to just change the oil every 10,000 miles and forget about it. It is a lie that is costing the average driver up to $400-500 in premature transmission rebuilds and engine replacements before the car even hits its 10th birthday. The system is designed to keep you clueless because a car that lasts forever doesn't make money for the service department. I've spent 30 years on the grease-stained side of the service counter, tearing down engines that failed way too early and looking at components that should have lasted decades but were reduced to scrap metal. Just last year, on January 9th, 2025, a pristine 2019 Toyota Camry rolled into my bay. The owner was a meticulous guy. He had a binder full of service records, changed his oil every 5,000 miles, well ahead of the factory recommendation, and washed the undercarriage every week. He was the dream-used car owner. But as he drove up to the lift, I heard it. A faint, metallic tap on the cold start that faded as the block warmed up, paired with a distinct, unsettling thump on the 1 to 2 gear shift. The car only had 51,000 miles on the odometer. He looked at me, completely defeated, and said it wasn't even a sound he could fully describe. It was just a feeling that something underneath him was dying. He thought he did everything right. The dealer told him the car was fine, threw no codes, and had no warning lights. But he was making 4 minor, seemingly innocent movements every single day behind the wheel, movements that 90% of modern drivers make without a second thought. Those 4 habits were quietly chewing through his valve train and glazing his transmission clutches from the inside out. Here is what the marketing departments and the slick showroom brochures will never admit to you. Modern Toyotas are tougher than the competition, but they are absolutely not invincible. Engines like the ultra-reliable 2AR FE, the newer direct-injected A25A, and the robust V6 lines are masterpieces of engineering. They are designed with incredibly tight tolerances and advanced metallurgy. But that engineering brilliance is exactly what makes them a ticking time bomb if you treat them like old, low-tech machinery. These power plants are so overbuilt that they tolerate immense internal stress without throwing a check engine light or sputtering. They don't complain, they just absorb the punishment silently, masking the damage for years. You think your car is running perfectly because it idles smoothly, but underneath that plastic engine cover, a silent war is being waged. By the time you actually hear a tick or feel a transmission shudder, the damage isn't starting. It is already done, usually culminating in a massive repair bill right between the 80,000 and 140,000 mile mark. I see it every single week in my shop. Beautiful RAV4s with prematurely worn cam followers, late model Highlanders with severe oil consumption issues that started so gradually the owners never noticed the dipstick dropping, hard-working Tacomas with intake valves so choked out by heavy carbon fouling that the engine is literally suffocating. None of these vehicles were neglected by their owners. They weren't abused on racetracks or driven through deep mud. They were simply driven the way modern life demands you drive a car, and that is the exact root of the problem. The daily routine of the modern commuter is fundamentally at odds with the mechanical reality of how these advanced powertrains function. Every time you get behind the wheel, you are interacting with a complex web of hydraulic pressures, electronic solenoids, and thermal dynamics. The pedals under your feet, the buttons on your dashboard, and the shifter in your center console aren't just switches, they are commands that alter physical forces inside the machine. Right now, millions of drivers are executing these commands in a way that creates measurable, irreversible wear on their drivetrains every single day. Your car is likely one of them. Let's break down the first hidden assassin, because it is a habit that feels completely harmless, almost natural, to every driver on the road. It is the act of pressing the accelerator pedal within the first 10 to 15 seconds of a cold start. Think about your morning routine. You run out to the car, you're running 5 minutes late for work, you hit the engine start button, the motor catches instantly, and before the tachometer needle even has a chance to settle down to a normal idle. You've already slotted the transmission into drive, and your foot is pressing down on the gas to roll out of the driveway. Why wouldn't you? Modern electronic fuel injection is incredibly efficient. The computer adjusts the fuel-to-air ratio perfectly in microseconds. The engine doesn't cough, it doesn't shake, and it feels completely ready to run the moment it fires up. It feels worlds away from the carbureted cars of 30 years ago that required you to sit there pumping the pedal just to keep the block from stalling. Because the car feels ready, you assume it is ready, but mechanically, it is starving. When your vehicle sits overnight in the driveway, gravity goes to work. Over 8 to 12 hours, almost every drop of engine oil drains out of the upper cylinder head, flows down the oil passages, and pools at the very bottom of the engine in the oil pan. The camshafts, the valve lifters, the timing chain guides, and the complex variable valve timing actuators are left sitting in the dark with nothing more than a microscopic, sheer film of oil clinging to the bare metal surfaces. The moment you press that start button, the mechanical oil pump begins to spin, drawing oil up from the pan and forcing it through the oil filter and up into the engine block. But full hydraulic oil pressure does not happen simultaneously across the entire engine block the exact microsecond the engine fires. It takes time. The fluid has to fight its way up to the highest physical point of the engine, the cylinder head. In a modern Toyota equipped with advanced VVTi or dual VVTi systems, those variable valve timing solenoids and cam phasers are completely dependent on full, steady hydraulic oil pressure to lock into their proper positions and function without slop. The hydraulic timing chain tensioner requires that same pressure to keep the heavy steel chain from whipping against its plastic guides. The lifters need that fluid to cushion the massive forces of the valves opening and closing hundreds of times a minute. None of this critical stabilization happens the instant the motor catches. It takes several seconds for the oil galley to prime, and in cold winter weather, that window of vulnerability stretches out significantly longer as the thick, cold fluid resists flowing through those tiny, precision-drilled passages. Now, look at what happens when you throw a load on the engine during that critical window. You put the car in gear and press the throttle. The engine speed jumps from a high start idle up to 2,000 RPM. The valves are now slamming open and closed at double the speed. The camshaft lobes are forcing their way against the lifters with immense mechanical force. But the wave of pressurized oil has not fully arrived to create the necessary hydrodynamic barrier between the moving metal parts. What you are doing is forcing metal to grind directly against metal under a depleted, microscopic film of lubrication. You won't hear a catastrophic bang. You won't feel a violent vibration through the steering wheel. The over-engineered components absorb the hit, but in those 5 seconds of immediate driving, you have just inflicted more microscopic wear on your cam lobes, your bearings, and your valve train than you would have caused during an entire hour of sustained high-speed highway driving with a fully warmed-up engine. Multiply that single morning mistake by 2 times a day, 365 days a year, for 5 or 6 years. The wear compounds exponentially. This is the exact reason why Toyotas that should run as silently as a Swiss watch start developing that distinct, annoying cold start valve tick at 90,000 miles. It isn't a manufacturing defect. It isn't a bad batch of steel from the factory. It is the physical manifestation of thousands of dry cold starts finally catching up to the valve train. The remedy for this specific issue is so simple it borders on ridiculous, yet almost no one has the patience to do it. All it takes is 20 to 30 seconds of pure stillness. When you start your car in the morning, do not touch the shifter. Do not touch the gas. Let the engine run, let the oil pump do its job, watch the tachometer drop slightly, and let the hydraulic systems completely prime. You don't need to sit there for 5 minutes wasting fuel like your grandfather did with his old V8. You just need to give the oil pump a fair head start. Once you finally shift into drive, keep your input incredibly gentle. Avoid heavy acceleration and keep the engine speed under 2,500 RPM until you see the temperature needle on your dash actually begin its climb toward the middle. That is the entire secret to preserving the top end of your motor. But that is just the tip of the iceberg, because the second habit is taking place in every suburban grocery store parking lot and driveway in the country. And it is actively shaving years off the life of the most expensive component in your drivetrain. It involves a lazy movement of the wrist that feels completely natural when you are in a rush, but it is forcing your transmission to do a job it was never physically designed to handle. And if you think your modern transmission is immune because it has 8 speeds or a fancy hybrid badge on the trunk, you are in for a very rude awakening when you see what is happening inside the gear case. Here's the fix most dealers won't mention, because they would rather sell you a $6,000 replacement transmission than a simple habit shift that costs you absolutely nothing. When you slide that shifter from drive to reverse or reverse to drive, while your Toyota is still creeping at even 1 mile per hour, you are bypassing the service brakes and forcing the internal components of your transmission to act as the anchors for a 2-ton vehicle. Let's look at the mechanical reality of what happens inside modern Toyota gearboxes, like the ultra-common 8-speed automatic units, or the electronic continuously variable transmissions found across their entire hybrid lineup. These gearboxes are incredibly compact, sophisticated engineering marvels. They rely on tightly packed planetary gear sets, which are rings of gears rotating around a central gear. To change direct speed or direction, the transmission's computer uses hydraulic fluid pressure to squeeze clutch packs and brake bands together. When you are moving forward, one set of clutches is locked solid. When you shift to reverse, the fluid instantly reroutes to release those forward clutches and clamp down on a completely different set of reverse clutches to force the gears to spin backward. The system is designed to perform this handoff when the drivetrain is completely steady, see. But when you make that lazy, rolling shift in a parking lot, you are forcing the incoming clutch pack to violently clamp down on components that are still spinning in the opposite direction. The clutches don't snap on day one. Instead, they slip violently for a fraction of a second, fighting the momentum of the moving car. This shearing force creates immense friction and intense localized heat. The friction material on those delicate clutched discs, which is only a few millimeters thick, begins to glaze, burn, and shed microparticles of material directly into your transmission fluid. Over time, those hot spots destroy the friction coefficient of the plates. That is exactly how you develop a harsh, clunking 1-2 shift or a terrifying transmission shudder at under 60,000 miles. The fix for this is an absolute, non-negotiable, step-by-step physical habit that requires 0 tools, $0, and exactly 1 extra second of your time. First, when backing out of a parking spot or a driveway, keep your foot hovering over the service brake pedal. Do not even lay a finger on the gear shifter while the vehicle is in motion. Second, press the brake pedal down firmly until the vehicle comes to a complete, dead stop. The chassis must not be rocking, pitching, or creeping forward or backward by even a fraction of an inch. You want the physical brake calipers at the wheels, which are cheap, easily replaceable wear items designed to handle friction to absorb 100% of the car's kinetic energy. Third, only when the car is completely motionless, move the shifter smoothly into drive. Hold your foot on the brake for an extra half second to allow the hydraulic fluid to fully fill the clutch circuits and lock the gear set in place before you transfer your foot to the accelerator. I watched this exact fix save a customer named Sarah, who brought her mid-sized Toyota crossover into my shop. She was convinced her transmission was completely shot because every time she put it in gear, it would pause and then violently slam into engagement, throwing her forward in her seat. A local dealership had already quoted her $5,800 for a total transmission replacement. When I scanned the computer, there were no mechanical codes, but when I rode shotgun with her, I noticed her habit immediately. She would back out of her driveway, hit the shifter into drive while still rolling backward, and stomp the gas. I told her to keep her wallet in her pocket. I flushed her fluid to get rid of the suspended clutch debris, and made her promise to use the dead stop method for 30 days. 2 weeks later, she called me up. The slam was entirely gone, the shifts were smooth as silk, and she saved thousands of dollars just by letting her brake pads do the stopping, instead of her transmission clutches. But you have to be careful, because there is a massive misconception floating around the internet that modern electronic transmissions have built-in safeguards to completely prevent this kind of damage. People think, the car is smart, it's fly-by-wire, the computer wouldn't let me damage it. That is a dangerous mistake. While the onboard computer does have shift protection logic to stop you from throwing the car into reverse at 50 miles per hour on the highway, it permits shifting at low parking lot speeds because it assumes you are executing a necessary maneuver. The computer allows the shift, but it cannot change the laws of physics. If the wheels are turning, the clutches are burning. This brings us directly to the third daily habit, that is cooking engine oil and transmission fluid under the radar. Sitting at long red lights or drive-through lanes with your foot firmly on the brake while leaving the shifter in drive. When you sit at a complete stop in drive for 2, 3, or 4 minutes at a time, your engine is still spinning at idle speed, but your wheels are locked by the brakes. The component connecting the two is the torque converter, a heavy metal donut filled with hydraulic fluid. Inside that converter, an engine-driven impeller is violently churning and throwing fluid against a turbine wheel that is held completely stationary by your brakes. Because the fluid can't turn the turbine, all that mechanical energy from the engine is converted directly into pure, unadulterated heat. Modern Toyota automatic transmissions are designed to operate happiest when the fluid stays well below 200 degrees Fahrenheit. But when you sit in heavy summer traffic or wait in a 20-minute fast food line with the transmission fighting the brakes, that fluid temperature can spike way past the safe zone. Transmission fluid degrades exponentially with heat. For every 20 degrees you push it past its optimal limit, you cut the life of that fluid roughly in half. It oxidizes, loses its viscosity, and transforms from a clean lubricant into a thin, dark liquid that can no longer protect the delicate bearings and valve bodies. At the exact same time, your engine is suffering at a hot idle. The mechanical water pump is spinning at its lowest possible speed, restricting coolant flow through the block. The oil pump is generating minimum pressure. There is no natural ram air flowing through the front grille, so the radiator fans have to work overtime just to keep the engine from overheating, all while the air conditioning compressor is hammering the motor with massive parasitic load. It is the absolute worst, highest stress environment for a stationary vehicle. The fix for this is the neutral drop method, and it is a habit every professional driver uses to preserve equipment. Step 1. Whenever you approach a traffic light that you know is notoriously long, or you find yourself trapped in a slow-moving drive-through lane where you will be stationary for more than 30 seconds, look at your surroundings. Step 2. Keep your foot on the brake pedal and simply slide the gear selector forward into neutral. Step 3. Release the tension. The moment the transmission clicks into neutral, you will feel the entire chassis relax. The engine idle will instantly smooth out and drop slightly. By separating the engine from the drivetrain, you have completely unloaded the torque converter. The impeller and turbine are no longer fighting each other. The fluid stops shearing, and the heat generation inside the transmission drops to near zero instantly. This allows the transmission cooler to actually do its job and bring the fluid temperatures down. It also removes the heavy load from the engine, allowing the coolant and oil to flow more easily and cool the internal engine components down before you start driving again. When the light turns green, you simply click it back into drive and accelerate normally. The biggest warning here is to avoid the common mistake of shifting all the way into park at a red light. Shifting into park engages a mechanical locking pin called a parking pawl inside the transmission case. If you are sitting in park at a light and another vehicle rear-ends you, that impact will violently snap that metal parking pawl right off inside the transmission, sending metal shrapnel through your gears and instantly destroying the entire unit. Neutral keeps the transmission completely safe from impact damage while providing all the cooling benefits. Now, implementing these fixes for the first 3 habits will easily add 100,000 miles of life back to your vehicle. But all of that effort is completely wasted if you are still committing the fourth daily habit. This last mistake is the single fastest way to destroy a modern Toyota engine, and it is happening every single time you pull back into your driveway after a long drive. By taking control of these four small daily habits, you aren't just preventing premature mechanical failures. You are unlocking the true 300,000-mile capability that Toyota engineered into your vehicle from the factory. The long-term return on investment for this shift in driving behavior is massive. When you stop cooking your oil on hot shutdowns, eliminate dry metal friction during cold starts, protect your clutches during rolling directional shifts, and dump transmission heat at long lights, you directly alter the wear curve of your entire vehicle. You will experience sustained, factory-spec fuel economy because your piston rings remain completely free of carbon buildup, maintaining optimal cylinder compression for years. Your transmission will hold on to its crispest, factory-fresh, shifting characteristics past the 250,000-mile mark because the fluid hasn't been oxidized into varnish. Most importantly, you completely erase the anxiety of the dreaded, unpredictable 100,000-mile major breakdown, keeping thousands of hard-earned dollars out of the dealership's service, till and squarely inside your own bank account. But changing your driver inputs is only the foundation. To truly maximize the lifespan of a modern Toyota, you need to implement a few complementary maintenance habits that work hand in hand with your new operational routine. First and foremost, you must reject the manufacturer's heavily advertised 10,000-mile oil change interval. The 10,000-mile recommendation is a marketing and regulatory strategy designed to lower the estimated cost of ownership for fleet buyers and help the manufacturer meet corporate environmental metrics. It is not designed to make an engine last 15 years. In the shop, under a microscope, we see that modern 0W16 and 0W20 synthetic oils begin to experience additive shear and lose their ability to suspend abrasive carbon particles around the 5,000-mile mark, especially in direct-injected or turbocharged engines. Change your oil and filter every 5,000 miles or 6 months, whichever comes first. When you pair clean, high-quality synthetic oil with a patient 20-second cold start idle, you eliminate top-end valve train wear entirely. Second, establish a strict transmission fluid service schedule. Toyota often labels their automatic transmission fluid as world standard or lifetime fluid, claiming it never needs to be changed under normal driving conditions. Let me tell you from experience, the only true definition of lifetime fluid is fluid that stays in the gearbox until the transmission dies. If you want the transmission to live, you change the fluid. Perform a simple drain and fill of the transmission fluid every 60,000 miles for standard automatic gearboxes, or every 90,000 miles for the planetary-based eCVT units in the hybrid models. Never use high-pressure flushing machines, which can force dislodged clutch debris into the delicate passages of the valve body. Stick to a gentle gravity drain and fill using genuine fluid. When combined with your new habit of stopping completely before shifting into reverse, this routine ensures your transmission clutches will never lose their grip. Third, pay close attention to your engine's thermal management system. Modern Toyotas use complex electric water pumps, electronically controlled thermostats, and active grille shutters to get the engine hot as fast as possible for emissions reasons. This means the cooling system runs under higher pressures and tighter tolerances than older cars. Once a month, pop the hood and inspect the coolant level in the translucent expansion tank when the engine is completely cold. Look for any signs of a crusty, pink crystalline residue around the water pump pulley or the radiator hose connections. This is the classic calling card of a slow Toyota coolant leak. Catching a minor coolant drop early prevents a localized hotspot from warping your cylinder head or cooking the turbocharger oil lines during a highway shutdown. Now, as you implement these precision habits, there is a technical trade-off you need to understand regarding modern driving modes. Many modern Toyotas come equipped with a drive mode selector offering Eco, Normal, and Sport settings. To protect your engine from internal carbon accumulation, I strongly advise against leaving the vehicle permanently locked in Eco mode. Eco mode is highly optimized to help the manufacturer achieve specific fuel economy ratings. It forces the transmission to upshift as early as mechanically possible, often dropping the engine into an exceptionally low RPM range, sometimes down to 1200 or 1300 RPM, while you are cruising under load. This state is known as lugging the engine. When an engine lugs at low RPM with a wide throttle opening, combustion temperatures inside the cylinders drop slightly, which sounds beneficial, but it actually promotes incomplete fuel combustion. This incomplete burn generates a significantly higher volume of soot and raw carbon. In direct injected engines, this soot sticks directly to the backs of the intake valves and packs tightly behind the low-tension piston rings, leading to heavy valve fouling and oil consumption. The trade-off here is simple. If you select normal, or occasionally slip the car into sport mode during city driving, the transmission will hold its gears slightly longer, keeping the engine operating in its optimal efficiency bandwidth between 2,000 and 3,000 RPM. This higher gas velocity naturally sweeps the combustion chamber clean and prevents carbon from baking onto the metal surfaces. Yes, you might notice a microscopic drop in your average fuel economy, perhaps a fraction of a mile per gallon. But you are trading a few pennies at the pump for thousands of dollars saved in top-end, walnut blasting services and engine decarbonization pros. Doers. It is a trade-off that makes absolute mechanical sense. At the end of the day, you have to realize that the relationship between you and your vehicle is entirely in your hands. The automotive industry has spent billions of dollars trying to turn car ownership into a passive, hands-off appliance experience. They want you to just turn the key, drive without thinking, ignore what happens beneath the sheet metal, and blindly trust a corporate maintenance schedule that is optimized for the warranty period, not the long haul. They want you to remain a consumer who is entirely dependent on the dealership network when the vehicle prematurely wears out. But the moment you understand the physical reality of oil pressure, clutch engagement, and thermal dissipation, you break out of that system. You are no longer just an operator steering an appliance. You are a technician, an insider, a custodian of an incredible piece of machinery. You possess the exact data and the practical habits required to outsmart the planned obsolescence of modern manufacturing every single time you start your car and wait those 20 seconds for the oil pressure to stabilize. You are actively preserving the engine. Every time you bring the chassis to a dead, authoritative stop before moving the shift lever, you are choosing to protect your transmission clutches. Every time you shift to neutral at an agonizingly long red light, or let the engine breathe for 90 seconds after a hard highway run, you are taking a stand against the silent wear that claims so many vehicles too early. You have the knowledge, you have the tools, and they didn't cost you a single dime to acquire. Treat your machine with the mechanical respect its engineering deserves, and it will reward you with rock-solid, unwavering reliability for years and hundreds of thousands of miles down the road. You are in the driver's seat now. Keep it running right.